Hello, everybody. My name is Matt Timek. I work here at Bucks County Community College, and I've been passionate about 3D printing for the past decade. I'm so excited to be your moderator here today and have these amazing industry experts here with us. We're going to get started. If you guys wouldn't mind saying your name, your company, and what you guys do.
Sure. I'm Brad Chandler. I'm with Allegheny Educational Systems. We are a reseller for more than 40 years in the technical education market that covers a gamut of 3D printing to laser engravers to CNC machines and pretty much anything that K through 12 up to university level could use in training. And we're proud to be here. Thanks.
Good morning. I'm Dave Jankowski. I work for a manufacturer based in State College. We manufacture a metal 3D printer. I assume a lot of the folks in here have done 3D polymer printing, right? Well, there also is an application space out there for metal 3D printing.
I'm Kyle Davidson. I'm part of the team at AON3D. We're a team focused on high temperature polymer printer. So specific applications, typically in aerospace, defense, manufacturing, and we really focus on printer hardware and then software to help make it easier for the user.
Awesome. Thank you so much. So let's get started with kind of covering the fact that 3D printing has changed a lot in the past decade. From what was an incredibly expensive industrial machine with expensive materials and a high barrier to entry to now being able to buy a printer for $200, have it in your home. What has that change affected your companies? What do you think about how we can bring 3D printing more to the mass market, have it in houses?
I have a background in industrial design. I used to teach at the Art Institute and at Philadelphia University in industrial design, model making, and prototyping. So from model making and prototyping, it used to be that you had to be a pretty good sculptor. You used to have to know your way around a standard machine shop. You used to have to know how to make silicone rubber molds and all that stuff in order to make a model of any sort of design. Whether that was an architectural model, whether that was designing a new microphone housing. With the advent of 3D printing, when I was a teacher, my first 3D printer was a Stratasys BST 768. That thing could print one material. It had some breakaway support to it, and that was a $30,000 printer, and that was a good price at that time. That was sort of the cheapest price to enter that for a school. That, of course, took grant money to do that. And so, as Matt said, the barrier to entry has gone way down since that time. I'm aging myself there, but that's a good 20, 22 years ago when I had that machine. And so allowing not just polymer printing, but all of these other materials to be printed has lowered the barrier, obviously, and allowed for designers, engineers to be able to iterate a lot better. So instead of taking forever in the machine shop to make one prototype in maybe a week, now you're making multiple prototypes overnight.
And maybe, Dave, could you touch on, for your company, which does metal 3D printing, what does that iteration and that rapid prototyping mean for industry?
Sure, that's a great question. Kind of following on from Brad's comments, plastic or polymer 3D printing has been around for a number of years. And metal 3D printing has also, but it's only been available to the larger companies or the larger, more well-funded universities and so forth. So as this price barrier gets lower and lower with newer technology and newer suppliers and manufacturers, it makes the technology more accessible. In terms of how that kind of relates to the application space, I mean, one thing that's super cool is all of the young folks here, right? I mean, the young folks, how many of you have done a model or used a 3D printer? Raise your hand, right? And even some of these old folks up front, right? But I mean, that's what's cool about this technology is frankly, it is not intimidating. You know, you don't have to get a machining apprenticeship in order to use it. You can simply do a design, import it into a printer, and make your part. You know, so kind of combining this accessibility in terms of the technology and the young folks now have access to it. I'm from State College, Pennsylvania. You know, the junior highs have printers. I mean, a lot of them. So having access and understanding the technology is going to prepare you to then look at these more challenging applications and prepare yourself for moving, you know, into industry and so forth.
Kyle, do you want to touch on some of that that we just spoke about with Dave?
Yeah. So my first printer was a Prusa Mendel. Feel free to Google it. It was an absolute nightmare to build and took a lot of commitment. Definitely took a lot of commitment. You had to make your own models, things like that. So you really have to be bought into that idea at that point. And now it's, like you said, you can buy a $200 printer, you can go on a website like Thingiverse, download models, and at least learn what you can start to do with 3D printing. And then you can start to take that and manipulate that into where it's more practical in your life. So definitely making a huge change there with the pricing.
Absolutely. So we mentioned Thingiverse, right? So what projects or applications that you've seen out there already right now that people are printing that have been inspiring to you, that have been, oh my gosh, I can't believe people are using a printer for this right now, that might be available to someone. Yesterday I saw a TikTok video about an illusion that was 3D printed, and the parts perfectly fit together. The tolerances were incredible, and it was a spiraling chain that manufacturing traditionally with a CNC would have cost hundreds of dollars. So what projects have you guys seen that are like, wow, this is pretty cool?
Okay, I could take that a couple ways. I started in large format, and I've worked on projects where we've printed cars and drove them off of trade shows. But on a more practical approach is, you know, most of the people in the stands right now, you can start doing things like tooling that are, like if you are interested in carbon fiber, you can print a tool for carbon fiber right now and do an out-of-autoclave mold in your house. You can print concrete molds and start to do that. There's people that are getting furnaces and doing loss casting. So you're burning out the part and then putting metal inside of it and making metal parts. And you can do all that at your house right now for relatively inexpensive. And that will carry over very well into industry.
Absolutely. Any other projects?
Oh, great. Yeah, it's, again, really, you know, it's what your mind can imagine to do. If you can design it, you can print it. I mean, that's the beauty of it and so forth. You know, when you kind of compare additive manufacturing, as our technologies are, to subtractive CNC machining, they complement each other. One is not going to replace the other, but they complement each other. For example, in additive manufacturing and 3D printing, you can print internal features. And what that means is if you have this bottle, and imagine this bottle is solid polymer or solid metal, as you print it, you can actually put a feature internally that perhaps helps the performance. You know, to manufacture that any other way could be very challenging. So this internal feature capability, if I'll kind of delve into the industrial side a little bit, for like tool makers and injection motors and blow motors and so forth, you have something called conformal cooling, which helps minimize the temperature of that metal part. To put those conformal cooling channels in, extremely difficult to do with any other technology than metal additive manufacturing. So this internal feature, fine features, and one of the more unique applications we had is we were actually contacted by 2 universities within about a week of each other. There must have been some National Science Foundation grant going on. They wanted us to print replacement knees for bees. Now, at first I thought we were kind of being spammed, right? But you know, I talked to the professors. They said, no, this is a grant we're applying for. So they said, what's it going to cost? I said, well, I'll print those for free because I can print 1,000 of them. I said, I just want to see how you replace those on those bees, right? You know, but then again, you know, so that's kind of on the unique signs, so forth. But tooling applications, molding, end-of-arm fixturing, and so forth. Watch housings is a great one. Customized components, customized parts, I think are really where this additive manufacturing really shines.
I'll second that. Also, the medical applications. So I'll give you 2 examples. We have a little wiener dog at home, a little dachshund. I didn't know this, but apparently it's a pretty common issue for dachshunds to have a leg that sort of like turns in on itself a little bit, sort of a bowed leg. And it's such a common thing that in veterinary schools, they train students that are training to become a vet, they train them on how to do a little simple operation where they cut a little wedge into the bone to basically straighten the bone out. So at University of Pennsylvania, in their biomed lab, they 3D print dachshund foreleg bones just out of regular ABS plastic, your standard FDM filament style printer, just for students to practice that specific cut. And it's that common of a thing that they're not going to get cadaver dog bones basically to practice that. 3D printing a little plastic piece helps those students prepare for the real world. 15 years ago, just with ABS plastic, I was at Stony Brook University, which is attached to a hospital. And this stands out to me. I've told this story to a lot of people. I was meeting with a doctor there who had a very old 3D printer. It's just printing, again, FDM-style polymer filament. He had scans of patients' aneurysms. Now, I went to art school. I wasn't sure what an aneurysm was. It's basically a blood vessel that's swollen inside the brain. That thing can kill you, okay? This doctor 3D printed just a little aneurysm because they come in all shapes and sizes in the various patients. Every patient is going to look different. That aneurysm is going to be a different shape, and there's different surgical techniques to fix these different shapes. All he did was take a little latex rubber, apply it over the 3D print of that particular patient's aneurysm, and then could go and practice whichever surgical technique is going to work best to save that patient's life. I get chills just telling the story, but he had a display case full of 3D printed aneurysms and he said, this saved somebody's life, this saved somebody's life, this saved somebody's life. Because otherwise, before that, the surgeon, a brain surgeon, has to go and just figure out where it is and then what they're going to do in the moment. This allows them to practice and save lives. And again, I said that's 15 years ago. The 3D printing technologies that we have available in metal and other more advanced polymers is just helping the medical industry in leaps and bounds.
That's incredible. Dave, do you want to talk on?
In fact, let me just make a quick comment on that to add. One of the coolest presentations in additive I ever saw was by a surgeon from the Mayo Clinic up in Minnesota, where they do all this advanced surgery and so forth. And he had been using additive for 15 to 20 years to replace components or to help people live a full life again. I mean, it was fascinating how he used it. I mean, they were so far ahead of what I thought was practical. So this medical side, because everybody's skull is different, right? Everybody's tooth is different. Everybody's femur is different. And how do you customize their replacement, the parts in order to allow folks to live a full life again?
Yeah, it's incredible, the applications for the medical industry. Like you're saying, everything is so personalized. As we look at the industry as a whole, what do you see some trends that additive manufacturing and 3D printing is going from large scale, like what the concrete printers are doing, to in the home? What's some things going on right now broadly in the industry?
I think one of the things that I see going on is a lot of companies are transitioning from prototypes to figuring out how they can use it for production. And really going through, and part of that is how do you validate parts, so they're getting systems on how to validate parts, how to design qualified parts, and then a lot of that starts with the people in the audience, because my generation didn't have 3D printers growing up, so that was a new thing for me, and super interesting, but many of you have had that your whole lives, and it makes it a lot easier to start considering that, and then when you bring that new train of thought into the workplace, you're really helping people to understand, okay, maybe we can do more with additive. Let's figure it out.
Man, you took my words away. I mean, exactly. I mean, just the application and the growth areas and so forth, making it more accessible. And as Brad pointed out earlier, making it more accessible and affordable. Now we manufacture a printer, a metal printer, a little bit higher price than perhaps a polymer printer, but less expensive than it was 10 years ago. So by bringing this price point down, it makes it more accessible for community colleges to purchase, or perhaps a tier 1 or tier 2 automotive supplier, or a small to mid-sized manufacturer. So that's number one, but also making it easier to use, making it simpler to use, so you don't have to have a PhD who's standing by watching this thing print 24/7 and make sure nothing screws up. So I think this whole affordability, accessibility aspect is really going to continue to widen the scope of applications and the organizations that can participate in this really cool technology.
So as you're mentioning the affordability, but what are some of the hurdles that people are still facing when they get the printer? What are some problems that people might come across?
I think actually along the same lines of additive manufacturing is engineers, designers, convincing the people with the checkbook at their companies to invest in the technology. I think being able to come to events like this to see the actual parts, to see examples, to see machines actually working, it's still, even being in the industry, it still amazes me some of the stuff we can make, as Dave said. It is amazing what some people are thinking through and able to do with the technology currently. And so I think being able to convince others and show them, hard examples of what it can actually do is really important, and that's a big hurdle sometimes for both educators and for industry.
Absolutely.
Yeah, something that we've seen quite a bit is there has to be real commitment on the organization which is acquiring the technology. There has to be a commitment in terms of personnel, in terms of of course, the capital expense. But I mean, it's and I can talk mostly on the metals printer side. That's kind of my background, and you can purchase the printer, which is great, but then you have to have a trained individual in order to operate it who understands the nuances of that specific technology. And there are a wide range of metal and polymer additive technologies, a wide range, and over in the exhibit hall, you're going to see a lot of them, right? So there has to be a commitment in terms of, we're going to commit an individual to really champion this technology and understand the software and understand the applications. And that's an area that, we've seen some challenges in with some of the industrial customers that we have, where they think they can buy it, load up a file, push a button, and go home. Maybe a year later you can do that once you fully understand the nuances of additive manufacturing. But initially, it could be a little bit of a challenge.
You can go so many different directions with this. I think it starts, additive is the Wild West right now, meaning that there's not a lot of universal standards for anything. And that really that really hurts when it comes to having that assurance that the part's going to come out good, that the operator's proficient, and on the operator point, you need somebody that takes ownership of it, and then you need people that are good to take ownership of it. And those are two different things. And really, machines have to become independent of the operator. We have to take the human out of the loop, I hate to say it, to really have successful prints and to be able to use these at scale, and to adopt them in, not just one facility and one printer, but, they have the same machine everywhere doing similar things, and there's repeatability. So I think that's some of the main challenges there. Additionally, they need to have a sensible ROI. When I started in additive 8 years ago, they would put a return on investment. They would look at the printer, they would understand how much one part cost, and they would compare that to their costs, and they would go, okay, this is much cheaper, I do it 100 times a year. And then what they didn't realize was it wasn't going to work 100% of the time. They probably needed to hire a dedicated operator to get this machine running. And then everything that we worked on was theory at best. So if machines can become easier to use, if people can take ownership of them and be successful with them, that's going to start to chart the path forward.
I don't know how many times I've printed something, tried to print it again, and the print failed. Whether or not it was an environmental change or whatever, humidity, whatever. But it has happened to me, and I'm sure it's happened to everybody else who has printed or has a home printer. So talking about that, and everybody loves the AI right now, and Kyle, I want you to touch on this first. Okay. How can AI change? How can the industry change to make what you're talking about, that future, a reality? Can AI do that? Can it help?
Got it. So we need AI all over the place. So one, we need people that can design models, and then we need ways to make model design easier. I use Solid Edge, I use Creo, I use Fusion. They are all a pain. To not sugarcoat it, they are not the easiest CAD tools to use. There's a lot of tribal knowledge, and then you have to understand how they like to approach things. So if AI can help with that process, that'll help a lot. Additionally, we're controlling a melt pool, whether it's polymers or ceramics or metals, it doesn't matter. You're controlling a melt pool, and to do that, it requires a certain skill set. And AI can really help to mitigate that and to help take what you want to do, take your intent, and then apply logic to it that helps it with more successful, more strength, and more assurance. So really, like my company, for example, we've been in high temperature additive for 8 years. We had machines that were very manual in the past, and if we would give promoter scores to our customers, how much do you like the machine? We would get 10s, 9s, and 1s. There was no 5s. It was all 10s, 9s, and 1s, and it was 100% operator. And then we would do things like we would go out to the ones, we'd go to their site, we'd train them, we'd ask them the same question. It's the same machine, they're doing the same thing, and then 2 weeks later they give it a 7 instead of a 1. That's what AI can fix. AI can take it to, it does what you want it to do. It's going to take time, it's going to take building models, but I think there is an inevitable path there.
And I would agree 100%. I mean, the whole AI side of metal additive, which I can speak to, is growing slowly. As we like to say, when we introduced our first printer at Xact Metal 6 years ago, it was functional, it printed great parts and stuff. It didn't have like a lot of intelligence inside of it. And maybe it's artificial intelligence, maybe it's machine learning, but we've gradually added more of these features that allow you to monitor, make decisions, and control the printer. And I do see it moving more and more in that direction. I mean, the operator comment is dead on. The operator can make or break an application, period. And we've seen it all the time. We'll get a phone call, hey, your printer's not working great. We'd start talking to the operator. We learn that perhaps he hasn't set up the print appropriately. Perhaps the part design, which he input, wasn't correct. You got to get these operators, I believe, more educated and more trained and so forth. So that's where this commitment from the organizations really has to come from. you got to make that commitment. We can chart it. Well, we do chart it. The really successful customers versus the partially successful customers, the real successful ones make this commitment to the facility, to the equipment, and more importantly, to the operator. And you click off all three of those boxes, and you're going to rock and roll with this.
So I see some of my customers and end users in this room. It's none of them that were any of the operators that had any problem with any of our equipment. That automating intent, I like that term that Kyle said. That's really absolutely where AI, I think, is going to help us, or machine learning, or whatever terminology that's going to become over time. Definitely the software, the software and the hardware itself has over the years gotten much easier and much more automated in order to figure out the intent of the end user and to make sure that supports are in the right place automatically, or enough supports are in the right place automatically, or that are you making sure that you have the right material in the machine? That's not the material you told me you were going to be printing with. There's all those mistakes. I've made them myself as an end user. So that automation and understanding our intent as a user of the product is definitely where I think AI is just going to be a support assistant, really, in the process.
Yeah, that's fantastic. Thank you, guys. So what do you think are some industries or applications that 3D printing hasn't been used in that it should? Or it's been used to prove concept, but really would change the game?
One that we know quite well is tooling and molding. And working with perhaps an independent tool shop or mold shop to integrate additive to complement their CNC or their subtractive processes. And to work for captive organizations too, where they have their own internal machine shop. And what we typically see is I have a lot of respect and time for machinists and folks who are in machining organizations. They understand metal, because I'm a metals 3D guy, right? They understand, that, price point and return on investment is important, right? And they're just comfortable with making these decisions. Where we've seen kind of the struggle is that it has to be a fully integrated solution, from the part design to the material selection to the printer operation, and they all lead to, of course, printing the successful part or the application. So, when we first started looking at molding and tooling really seriously 3 years ago, we thought we understood it. Well, we didn't. As one of my mentors told me, he says, Dave, he said, tooling isn't tooling. Tooling is a generic word, and you have 1,000 subgroups, right? And so we've learned, you really have to target within this large area of applications exactly what you want to go after, and what's the appropriate additive manufacturing method. We do something called selective laser mounting, which is great for certain applications, but other applications we're not very good at. And one thing to walk away from is investigate all the different technologies for both polymer and for metal and see which is most appropriate for you. Are you making big parts the size of this table where surface finish doesn't worry you? Are you making, those bee's knees, right? Different technologies have different advantages and so forth. And if anything, walk away understanding the difference in the technologies. I'm talking to all the young folks here, obviously. And then understanding where they plug into your applications, and we're talking to the more mature folks here.
Anybody else like to touch on that?
Yeah, definitely. One of my favorite applications that really hasn't been touched on, so if you're ever in Manhattan and you're on the FDR and you look across to Brooklyn, you see this giant building, kind of sparkles a little bit. So that was a building that my friends at Additive Engineering Solutions 3D printed all the concrete molds for that building. They saved a ton of money, and they have a window geometry that you'll never see again in your life. So it's a very interesting curvature to that, and it's very prominent if you're ever in the FDR in Manhattan. So I would like to see the concrete industry use it a lot more. I think medical is starting to warm up to it more and more. Now on the metal side, they have adopted it, but not to the extent that I would like to see. I know, I hope I never need a hip implant or something like that, but if I ever did, I hope it's 3D printed because it's custom, but it isn't always that way. Dental is growing at a rapid pace, and it needs to grow even more. And I think anywhere where there's a legacy manufacturing and a legacy way of thought, they need to start to consider 3D printing as a way to save money and get things done faster. And then when that transitions to the customer and the cost savings for the customer, then they can start looking at new ways to expand both of their businesses, and then they'll expand additive as well because they can see it as a win.
So what do you think leads? Is it a use case and you build a printer around it or a process around it? Or is industry taking existing things and improving on them, taking existing printers or methodology?
So, I think it all starts with a problem.
Yeah.
People just have problems. This takes too long to get. I'm spending too much money on this, which seems low value to me. Whatever it is, it always starts with a problem, and then you work backwards towards a problem. I don't ever think leading off with additive is the right way to approach a problem. There's so many different ways to, fix something. It just happens to be a really good one when you have high mix, low volume.
Yeah, don't just get a printer just to have a printer. Then you're just going to end up printing Yoda heads or something on it, the figuring out what the main application is going to be first is really key. That's a lot of conversations we have with schools. Is what's the main sort of parts? I know you don't know everything you're going to make with it, and understanding what you can make with it. So, that we're sort of in this very gray area now where there's still plenty of people in the industry that have sort of the traditional manufacturing, traditional machining mindset where, okay, you can't have an undercut in this particular part. We can't manufacture it in our traditional sense. You can't have that bolt hole particularly there. You can't have this curve there. If we're going to build this, it's going to take 14 separate parts. But in 3D printing, whether it's metal or polymer, yeah, you can print that all in one piece, not 14 parts, right? And so it's not really one application or even one industry. It's really within your particular industry or your particular area of study that you need to rethink how things were traditionally made and how they can be made better with 3D printing. For instance, I think there's I want to say it's the F-1A maybe. It's a fighter bomber for the Navy, I think. And they had a particular type of air duct that would have taken literally 14 parts just for that one piece of air ducting to assemble in standard sheet metal. But with 3D printing, it's one part. It's not prototyping. That's in the actual fighter bomber. And so there's things like that 3D printing allows you to turn the traditional thinking on its head in any application. And sometimes the traditional manufacturing is the right answer, but keep in mind that you can do it a different way.
So not only is it cheaper to make in this particular example than the 14 parts, is it faster to make, but it is more efficient. It has less potential for failure because of the less parts. So overall, it's better.
Yeah, and it also improved the airflow through that ducting that you couldn't do if it was going to be all those 14 parts. Yeah.
And Dave, we were talking before. Kyle, please go ahead.
Just to add something to that question, one, I think additive has kind of got over the hype curve, and that's been really refreshing because I've got some of the most ridiculous requests ever, such as can we 3D print beds or couches? And I've actually printed a bed. It was ridiculous, but we did it. And it's been great that we've got over that. You know, everything is going to be 3D printed, and you're just going to have a factory of 3D printers, and you're going to turn the lights out and go home. And the other thing is, people reach out to us because we have cool stuff at the end of the day. And that doesn't mean it's appropriate. So I tell people no all the time. I go, maybe you want to reach out to Xact Metal. We're not for you. So that's everybody here has probably done that. But we hear it all the time. So there's, you know, when we continue to get over that disillusion of what it can do and what it can't do, I think it's going to be better for everyone.
So maybe not printing a couch, right?
Yeah,
but
probably not. You can print a couch if you want. I have a chair. I haven't brought it in.
There you go.
But just don't do it at scale.
So where do you see the industry going in 3, 5, 10 years? What is the future of additive manufacturing, 3D printing?
Back to medical, I mean, the FDA moves really slow. So of course, when and fairly enough to make sure that materials are safe for biocompatibility. We have biocompatibility with Formlabs. We have biocompatibility materials with Stratasys and other companies as well. Once the biocompatibility question gets answered, you have way more applications open to you. We already are using them widely in dental. I think it's when we start to get, when eventually we get titanium hips out of Xact Metal that they can make them right now. They just can't, they're not allowed to put them in the human body yet. I think that future is really exciting, again, because it's so individualized and just makes a lot of sense.
Yeah, you know, there are 11, in general, 11 metal 3D printing technologies, right? And we represent just one of those 11 technologies. And of those 11 technologies, a lot of them have been around a long time. So the actual physics of it, I mean, how you melt the metal, how you generate that melt pool, how do you control it, you know, that's been around a while, right? So what we're seeing is adding more intelligence into the printer while maintaining a affordable solution and ensuring that we allow the user to understand the strengths and the limitations of these different technologies. I like your comment on the hype curve. Additive was oversold a lot. Yeah. A lot. And you know, look online now and look at some of these big companies who oversold on additive and see where they're at now. You know, and it is not the panacea. It's a great complementary technology. And for the right application, man, it'll be affordable, easy to use, easy to access, and you get a great return on investment. But if you choose the wrong technology for a given application and it doesn't work, it can be pretty painful. So it's make sure you investigate all these technologies. They're going to get smarter and stuff. There are always new ones, right, at universities. The PhD folks and everything are generating new technologies, but you know, they take so long to mature that I think those 11 metal ones, they're going to be around a while, and they each have their niche.
Yep, so on medical, for example, we can print a material called PEEK, which has the same density as bone and facilitates bone growth. So you can print it with a nice sparse infill and bone will grow towards it. The issue is there's no qualification on it, and there's no qualification in general. And back to the question of where will additive grow in the next 3 to 5 years, I think it's going to be a relatively modest adoption of additive because at the end of the day, we need organizations like ASTM and the National Institute of Aviation Research to really drive these standards. There's not a lot of people that are getting involved in standards for printing process, standards for feedstock, and things like that. And until we have those, there'll always be that, there'll be a reluctance and a necessary reluctance because there's no way to certify anything. And until we can cross over that, that's when we'll see the rapid growth. But until then, it's going to be people like you out in the stands that come in with a new mind that uses additive, and how do we use it more? That's going to be the big growth driver in additive, I think.
So talking about how do we use it more, there are a lot of young people in the audience here. If you're somebody who doesn't know anything about CAD, you're not particularly good at math, but you find 3D printing to be incredibly interesting, where do you recommend someone get started?
So that's where 3D scanning has become so applicable. If you don't know how to use MATLAB, I don't. Again, I went to art school, not engineering. If you don't know how to mathematically do that or code, you don't need to know that. If you're overwhelmed by CAD, CAD has gotten a lot better and easier to use. Again, more automated, simpler. But if you can't do that, but you can actually sculpt something, you can actually find the item in nature, you can 3D scan it. Now, there's other tools there then that you have to learn with 3D scanning. There's certainly no easy button with 3D scanning either. There's a learning curve for that type of software. But that's where you can capture CAD data. And I should clarify that, typically when we're drawing parts, that's parametric data, right? That is accurate dimensional data. 3D scanning is just taking point clouds in space, is just seeing surfaces. And so even if you do know CAD, and it's very hard to draw some of the very amorphous shapes of more natural objects, again, maybe the anatomy, that sort of thing, that's where 3D scanning really helps as well, capturing very, very complex curves and shapes, and then being able to duplicate them with 3D printing.
Anyone else want to touch on? Where should someone get started today?
All right, if you really want to get started in additive, buy a cheap printer. Buy a cheap filament printer. Buy a cheap resin printer. Watch videos on YouTube how to use it. Go on a website that has models, Thingiverse, printables. There's a lot of them. Get some models. Start to print them. Once you start to learn how to print, then you can start to figure out how to make things that you need for your life. Either that or find ways to make money with it. When I was young and 3D printed, I started to print vases and put pots in them and went to craft shows and would sell it just to pay for my hobby at the end of the day. So you got to dip your feet in at the end of the day. That's the easiest way to do it. Just dip your feet in. My first 3D scanner was an Xbox Kinect. It wasn't the greatest thing in the world, but I did scan a few things with it if you want to go that route. But you just got to go. You just got to move forward. That's it.
Yeah, I endorse that 100%. Get a printer, exercise it, make mistakes. Have the filament fall on the floor and have your mother or your boss scream at you and so forth. Just exercise it. I always like to tell the story. One of our application specialists is a young lady named Stevie Feltman. Stevie Feltman. Go online, go on YouTube and type in Stevie Feltman, right? And she started to do 3D printing because she liked the fact that she could model something and then she could actually print it. She said, that's pretty cool. And she started with filament 3D printers, right? Well, Stevie is also into this cosplay stuff, where she actually set up a side hustle where she would go to these cosplay places, and she would have on her costume, which she would 3D print a lot of the components. And she built a little turntable. These costume individuals would stand on this turntable. She would scan them with a cheap scanner. Then she'd go home and she would print out like little mini-me models of them and sell them for a couple $100, right? And just developing that kind of that innate knowledge of what this design for additive manufacturing involves. And the only way you can do that is by doing it. Only way you can do it is by doing it.
If someone was so inspired by our panel today that they wanted to pursue a career in the industry of additive manufacturing, what degree should they look at, or what career path would you recommend they take?
I'm going to pass it to Dave because that's basically where Xact Metal got started.
Yeah.
That's awesome.
Yeah, it's, again, we started up in State College, Pennsylvania, home of Penn State. And Penn State has one of the largest additive manufacturing curriculums in the U.S. and one of the most well-known additive manufacturing research and development areas and so forth. So we started to learn about the educational space. And in the educational space, frankly, for our type of printer, because of the price point and because of the powder that we use, really is from the 2-year technical college up through universities and different levels of programs, whether it's BS, Masters, or PhDs, right? So what we typically recommend is, again, I apologize, I don't know if Bucks has an additive program, yes?
Not a specific program, but we have a lot of printers and courses that touch on it.
Start that, take those courses, learn about it, get comfortable with the material. I think the material is an area we always kind of gloss over. Get comfortable with this innate knowledge of the material, whether it's polymer or whether it's a metal. That's why I love machine shops. Those guys are not intimidated by metal at all. And you talk to other folks who perhaps are unused to using a bandsaw, they get intimidated, right? So I think material courses are super important. Some major colleges, like at Penn State, they actually have a master's and PhD in additive manufacturing. And of course, they have electives and so forth. So it is a technology-driven curriculum, obviously. So if there's an additive course, take it. Materials course, take it. Get comfortable with math. You still have to do math. And I think the CAD/CAM side of it is pretty important too, because in a lot of applications, that's kind of the starting point in terms of generating your model and your part.
Fantastic.
I don't like math at all. So I went to art school, as I said. But so, there's sort of two sides of this. A lot of the people that run labs that we know in many schools either come from a art, design, or engineering background. The majority of them. But there's certainly other people from other industries that get into this for the various reasons. But typically, as Dave said, understanding materials, understanding how things work, that's important for you, not just to know, but to enjoy, so that you can really dig into the variety of technologies.
Yep, so I'll preface by saying additive is a very tough industry to get in, and if you don't love it, I wouldn't get into additive. I just wouldn't. If you don't absolutely love it and could stare at a printer for 10 hours on end doing the same thing, I wouldn't do it. What I would say is if you do want to do it, not to repeat what anybody else said, I would definitely look at material science or rheology, which is kind of limited in teaching nowadays, but still very relevant. And I take rheology classes in my spare time. That's how much I love additive, and that's my message to everybody is if you don't love it, I wouldn't bother. And the other thing is try to work your way backwards. So there's a lot of, additive is a contrast at this point. People still do things the majority of the way subtractive. So learn what the industry is doing right now. Love additive at the same time. Demonstrate to the world that you love additive. And that's how you're going to get in, because you're going to have the industry knowledge of what we're trying to change.
Yeah, I was kind of thinking about our team. We're a small team. We're 16 people. I mentioned Stevie. Stevie has a degree in art and design. All right. One of our top engineers is a certified welder, and then he moved into different roles and moved into additive and loved the technology and so forth. One of our software guys has a degree in software. We have a couple mechanical engineers. I'm a materials guy. It's just kind of the breadth of folks or the backgrounds that move into additive. And frankly, it's super cool to hear Stevie, the art degree person, working with Eli, who's a certified welder. And just the interchange between the two of them, it helps us, develop stronger products and solve tougher applications. So your point was very well taken, Brad.
My background is in art as well, and coming into learning about 3D printing and developing the passion for it, it's welcoming to everybody. You really could have any background. As we're wrapping up, is there anything you guys want to share about your specific companies, anything that we missed about the industry you want to share with our audience?
Sure. So just again, happy to be here. I'm with Allegheny Educational Systems. We have been a reseller of multiple technologies for, like I said, over 40 years. The reason we're here is because the reason I'm here is because I started as a customer. I bought my equipment from Allegheny. I then came to work for them as an applications engineer, even though I do not have a degree in engineering, and went and taught and installed equipment for other educators. So I have a passion for this coming from an educational background. I love walking into the schools, from middle schools to high schools to colleges, to see the new applications that they're using with the equipment we represent. We also then support and try to train and support our customers as best we can with the wide variety of technologies that continue to change, and that's sort of the exciting thing about it.
Awesome.
There are a lot of great technologies out there in additive, and a lot of really good companies. And so I would encourage you just to really keep an open mind in terms of learning about the different types of additive technologies and see where they can plug in. And of course, when you talk to an individual company, I can talk about Xact Metal and tell you where we think we plug in. But again, we're very honest like you are, and if it's not a good plug-in, we're going to say, talk to so-and-so or talk to so-and-so, because so really, this is a great opportunity for everybody in here to walk around and ask those questions. And for the students, I know your professors say there's never a dumb question. Well, there really is never a dumb question. So when you're walking around and you ask a question, don't be intimidated. It's because you're the future. And there's going to be a need for, there's a need for future additive there's a need for additive manufacturing technologists in the future. There really is.
I'm part of the team at AON3D. We do high temperature printing. Some interesting applications there, kind of a niche space. At the end of the day, I'll volunteer my time. So if anybody wants to talk to me about additive or anything, I don't know my booth number, but it's a small expo. So please stop by and just say hi, and happy to be honest as I possibly can with you.
Thank you so much, everybody. Please enjoy the rest of your day and enjoy the rest of the expo.